Okay. Ding, 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 ding. Sharing the wrong one. Okay, so okay, for your science, for science, we have already completed chapter 1, 2, 3. Okay, so there is only 5 chapters. We have already completed 3 chapters. For your information, your exam in September will be chapter 1, 2, 3. Okay, your exam in September will be chapter 1, 2, 3. So what we're gonna do is that we have finished everything till chapter 3 now. What I'm gonna do is that by tonight, I will send your parents another new book. Okay, I'll send your parents another new book. Okay, so we will continue with the Who Does Cambridge Science. Okay, so we will do revision from chapter 1.
We have a new book.
Yes, you will have a new book.
Again.
Again, isn't it nice to have a colorful new book? But this new book you don't need to print out. No need to print out. Okay, no need to print out. Okay, so basically the table of content here is similar with your, it's actually almost similar with your currently Cambridge University Press. Okay, so you see chapter 1 is learning about all about human and animals, skeleton and everything. So here chapter 1 also you're learning everything about human and animals. Then chapter 2 you learn about living things like the habitat, where they stay, invertebrates, vertebrates and all this stuff. Chapter 2, same thing, you're learning the living things, okay, but more in details in different way. Okay, so we have finished everything about biology. Okay, you see bio, physics, chemistry. So bio, we have finished everything about bio. So chapter 3, we learned about solid, liquid, gas. Okay, which is what is the matter, occupy space, what is the particle models. So this one is chemistry. Okay, so your exam in September will be bio and chemistry, chapter 1, 2, 3. Okay, so in December you will have another test which is more on physics and everything. Okay, which is magnet, electric, and sound. Okay, that will be on the later part. Okay. So let's do a revision on all the biology. But first of all, what we need to know is being a scientist, what do we do? All right, so Joanne, can you read the first sentence?
Okay, scientists are people who are interested in the world around them. They ask questions and find the answer by testing their ideas in different ways.
All right, so scientists, are they like very smart and know all the answers? No, they don't. What is their job? They are a researcher. They do like the test left, test right. It's like, hey, like this doesn't work, like this doesn't work. So they keep testing. All right, so they keep asking questions and find the question by testing their idea in different ways. So that's how science get the answer. So when science don't have the answer, does it mean it's not real? No, it's just the scientists don't know the answer yet. Like for example, coronavirus. Okay, at the beginning last year, will it like kill baby? We don't know, right? We say like baby is safe. Only adults will have problem, right? Because scientists haven't tested about baby yet. So that is why they don't know whether we kill scientists. The scientists don't know whether we kill baby. But now, does it kill baby or not?
Yes.
Yes, it does. So it's not that it doesn't exist, it's just we haven't do experiment that some things we haven't proven yet. Like for example, sometimes we say a lot of Chinese medicines and stuff like that is good or bad. We don't know because scientists did not do any tests about it yet. It doesn't mean it's not good, but it doesn't mean it's good yet. It's just we do not know. That's all.
And coronavirus also sent scientists tests and found them out.
That's right. Scientists is the one that found out about the coronavirus as well. Like the latest strain. Do you notice all of us are staying home, right, because of the pandemic? Am I correct? But you look at the COVID cases now. Is it increasing or is it reducing?
Increasing
Why we are at home, but why is it increasing?
because people also go outside and play and sports.
That's true. And the main reason is because latest there is a new strain of coronavirus. It's called Delta variant. This Delta variant is very contagious. Last time, one coronavirus, you can infect like maybe 1 people. I said 10 people will infect 9 people. That was last time. However, now this new strain, they are very powerful. Okay, so they're so powerful that one person that get this coronavirus can infect to 2 people. Let's say there's 10 that has this coronavirus, it can make into like 15 people that got the coronavirus. That is why the ratio becomes higher. So now we have a coronavirus. I told you about it. It's very important to get vaccine injection, right? Because that is, remember I told you a story about the vaccine? Is that the vaccine is that the coronavirus will fight. The vaccine is like the baby, it was like a baby virus inside our body. Then our soldier, which is our immune system, will learn how to fight. Then we win, right? But now the problem is the scientists haven't do experiment. This vaccine that we jab, do it know how to kill this Delta or not? So maybe when we injection of this vaccine, we should not get any coronavirus. Am I correct? But we don't know whether this injection that we have, does it know how to fight the Delta variant or not? So these are the things that still don't know. So scientists need to look out for it. So scientists need to do a lot of experiments to look for the similarities and differences. Okay, can Jensen read the next one, scientists?
Scientists look for similarities and differences. They sort things into groups so that they can identify names and classify them. An example is sorted in different animals in the sea.
Okay, so what they do is that they have to do a lot of experiments to identify them, classify them, name them. This is what all the scientists does. Okay, Harold, can you read the last one? Harold, are you there?
Scientists compare when happens and Example is putting different objects into water to find out which object
think. Very good. So scientists, they keep on thinking how to do the experiment. Is like, does it flow or sink? What kind of experiment? How to do a fair test? So scientists make observation using their senses. They take notes. They draw pictures to record what they find out. Scientists keep this information. So scientists share what they find about, and share it with the world. To find information, scientists read lots of books, look on the internet, and watch videos. You see, that's how they find a skeleton. Which kind of skeleton is this? They have to keep thinking and keep on doing research. And you see, scientists test their ideas. They look at the effect of one thing has on another investigation. So they keep on doing a fair test. So like the shoe length, oh, this one got 1%, 2%, and so on and so forth. It's like, oh, most of the people's shoe is 27 cm. So scientists' question must be measurable and look for that in their result. So they always need to record, must be have some kind of consistency. So today what I really want to focus at is how to do a fair test. How to do a fair test. Okay, let me share a video with you on how to do a fair test.
Farmer Bob. He's here to help us figure out how to run a fair test, which is a fancy way of saying a really well put together experiment. Farmer Bob has two fertilizers, A and B. He's wondering which will help his flowers grow the quickest. Farmer Bob's hypothesis is that the plants he treats with fertilizer B will grow taller faster because B is more expensive. That's his rationale. He will compare two flower patches. The patch treated with fertilizer A will be his control group because this is his normal fertilizer.
Okay, listen to the words that have, like, for example, controlled.
The patch that gets fertilizer B will be his experimental group. Farmer Bob is testing to see if fertilizer type affects flower height. That's because his hypothesis is that the type of fertilizer will actually cause a change in the flower height after 1 week. Both his control and experimental flower patches need to be treated the same way, other than that one is getting fertilizer A and the other fertilizer B. For example, they'll have the same amount of water, the same flower seeds, the same amount of sunlight. Those things that are kept the same are called constants. So remember, anything that's staying the same is called a constant. Anything that ends up changing during your experiment is called a variable. In class, we're going to go over the 3 types of variables you can find in an experiment: the independent variable, dependent variable, and confounding variables.
Random Panda.
Okay, so there's a few things we want to focus here. It's what is this big jargon words: controlled variables, experimental, and all this. Okay, so how do you do a fair test? Is that scientists think about and do different things in order to carry out a fair test. A fair test. Okay, everyone, please type this in the chat or write in your book also can. Okay, a fair test is a way to investigate a scientific question. Okay. Fair test is a way to investigate a scientific question. Okay, please type in chat. Okay, I'll write down in your book. I think actually better. All these are very important words. Okay, very good. Okay, next. What is the definition of hypothesis? This one very long. Hypothesis is a statement about a relationship between two variables. It is a specific, testable, predictable about what you expect to happen. Okay, a hypothesis, like for example, I give you an example. Okay, like for example, my hypothesis is that none living things can move. Okay, when hypothesis doesn't mean it is correct or not correct, but this is what I'm thinking. So I'm thinking that non-living things can move. So I really believe in it. So what I do is that I need to do a science test that only non-living things can move. It's like, which are the non-living things? Okay. Then it's like when I compare with living things, can living things move too and stuff like that. So the hypothesis sometimes can be true or sometimes can be false. Hypothesis sometimes can be true, sometimes can be false. So I will do all the experiment to see. So hypothesis is a tentative statement. It's like sometimes what I say about it. Okay, within possible and not possible. Then I predict what will happen and expect what did happen. Got it? Okay, so what I need you to do, just type the first sentence will do. Type what is hypothesis. Hypothesis is a tentative statement about the relationship between two or more variables. Okay. Okay, next. What is controlled experiment? Okay, what is controlled experiment? Controlled experiment, which means that one thing that doesn't change. Okay. Okay, so what is meant by controlled experiment, which is something that is constant? Okay, let me type. Control experiment is an experiment which all variable factors have been kept constant as a comparison in an experiment. Control experiment. Control experiment is an experiment in which all variable, like for example, okay. For example, for example, I give 3 flower pots. Okay, for example, I give 3 flower pots. Flower pot 1, flower pot 2, and flower pot 3. Okay. Let's just put the flower pot. Okay, so I put sand, sand, and sand. Okay, then this one, I put the seed, and I put the seed. Okay, this one I don't want to have any seed. So one I put under the dark house, one I put under the sun, because I want to see, does the seed need sunlight to grow or not. So I want to compare, is that one grow, one don't grow? Is it the problem of the sun or no sun, or is it because of the seed problem? So here I purposely put no seed. So that is actually a control. Okay. All right. Okay. So these are the few keywords you need to know. Okay, hypothesis, control, and also fair test. Okay, let me give you an example over here. When you want to do experiment, first thing you must always come with, think of what you want to find out. Ask a scientific question. Ask a what question or why question. Then investigation to test and measure the result. What will you answer your question? How can you test it? Okay, so first of all, you must always come with, okay, can you write that? Step 1 is start with a hypothesis. Step 1, come up with a statement. Hypothesis statement. That's step 1. Okay, write on the piece of paper. I think will be good. Step 1 is your hypothesis statement. Then number 2 is come up with a how to conduct a fair test. Okay, like for example, number 2, you see, what will you do to answer your question? How can you test it? What equipment you need? Okay, what you might need to measure? What are the equipments? These are the things that you change. Okay, so when you want to have a fair test, you must think of the equipment. Okay, at A, you need to think of the equipment. B, you need to think of what are the variables, which is things which is change. Okay, variables. Okay, C, which is what is a control. Okay, what is same? Variable is change, control is same. Okay. Then after this, Then step 3, you do an experiment. Okay, step 3, you do experiment. Keep your text fair, change only one variable for factor. Everything else must stay the same. So observe, okay, do the experiment. Then number 4, observe the cause and effect. Okay, experiment is all about the cause and the effect. Number 4 is observe the cause and effect. After that, number 5, you observe and you record your observation. This is the most important. Okay, or your so-called, this is the data, scientific data. So this is how number 8, you put in the data into a chart, and then after that, at the end of the day, the result of your test will help you to answer your question. So, and at the end of the day, number 6 is where you do the conclusion. Conclusion. So then the conclusion, you see your conclusion. Compare your conclusion with your hypothesis. See whether what you think is correct or wrong. Okay. Okay. Have you copied it into your paper? Have you copied it into your paper? If done, can you just type done? Okay, so let me share with you the steps. Okay, so you know how to do the FAIR test. Now let's share with you on the steps.
One of the great challenges in this world is knowing enough about a subject to think you're right, but not enough.
Have you ever had a question about the world? Like what plants need to grow? Or how to blow bigger bubbles? There is a way to find the answer to these and other questions that is used by scientists. It is called the scientific method. If you use it, you can be a scientist too. The scientific method is a way to ask and answer scientific questions by making observations and doing experiments. There are 6 simple steps to follow. First, ask a question or identify the problem you would like to solve. Second, make observations and do research about your topic. Observation means to study carefully. Once you have observed and researched your problem, you are ready for step 3. Form a hypothesis. A hypothesis is an educated guess about how something works. In order to be useful, a hypothesis needs to be testable. This means that you can actually test it and see whether it is true or not. After you have your hypothesis, move on to step 4. Design an experiment and test your hypothesis. When designing an experiment, you must be sure to only test one thing at once. You can do this by making sure to only change one thing or variable in each experiment. Everything else must remain the same. Once you have completed your experiment, analyze your data. To do this, you will look at the results of your experiment and try to figure out what it means. Finally, using your data, you can draw a conclusion. If your conclusion did not support or agree with your hypothesis, that's okay. It doesn't mean it was a bad experiment. Using the information from your first experiment, you may need to form a new hypothesis and create a new experiment to test it. Even if your conclusion does support your hypothesis, you may have a new question you'd like to test and can begin the scientific process all over again. The scientific method is a step-by-step way to solve problems and answer questions logically. Thanks to the scientific method, many important discoveries have been made about our world, but many unanswered questions remain. Would you like to help answer them? You can. Just remember to be scientific. Ask a question, make observations, form a hypothesis, design an experiment and test that hypothesis, analyze your data, and draw a conclusion.
Okay. So let's do. Okay, today let's do the scientific one first. Okay. Let's have Joanna first. Okay, Joanna. Joanna, you can control. First step, what should you do? If you don't know the answer, refer back to the chat. The steps I told you. Step 1. You want to find out something. So you create a sentence first. Form a hypothesis first. Okay, I'll give you 1 minute to do. I go for a quick toilet break. Okay, so step 1, observe. Oh no. Okay, no problem. Okay, so first step is that you actually not exactly correct. Actually, step 1 is hypothesis. Step 2, make a control. And after step 4, observe. Then step 5, then after that only collect, then only draw conclusion. This wasn't exactly correct also. Observe, it should be between a control and collect, analyze. Okay, no worries. Next one. Okay, next one. Here. Okay. Let's have Jensen. Jensen. So fast conclusion. Conclusion means you find the final answer. Hypothesis means you make the guess first. Alright. Okay, Jensen, ask question first, good. Then after that, you make a hypothesis. Always hypothesis is at the beginning. Okay, after you do a hypothesis, which means that, hey, maybe I think this will be like this. Okay. Then after only you do the experiment to test whether your hypothesis is correct or not. Okay, because the experiment is always test your hypothesis correct or not. Then after your experiment, you only organize the data, then you do conclusion. So normally your conclusion always compare with your hypothesis. Okay. Okay. Okay, let me see. Hold on, yeah. Okay. I got one more here. Okay, Harold. Harold, you there? Harold, you there? Okay, the first one. Must have a problem first. State your problem. Okay. Harold, how about you turn on your mic and tell me, then I'll help you to move. The first one. First one is state your problem first. After that, state your problem already, then you create a hypothesis. After you create a hypothesis, Then you do an experiment. After you do an experiment, you get all the information from the experiment. And then after that, oh, no. Oops. Sorry. So you need to have a question first. Then after that, only see what's the problem. Then after that, only hypothesis and experiment. Then after that, collect data and draw conclusion. Sorry, this part. State the problem first. Okay, state the problem first. Then only you get the information and ask question. Got it? Okay. All right. So that's pretty much today's. Oops. That's pretty much today. Today we focus on the scientific method. Okay. Tomorrow we will focus on the fair test. Okay. Tomorrow we focus on fair test. Okay. All right. So that's all for today. Only 2 homework for today. All right. Okay, that's all for class. Bye. Enjoy your tea break.